Good morning, everyone. So last year at CoLab, I gave a talk on a GenAI primer where we talked about some of the very basic fundamentals of this new technology that's just everyone's raving about, talking about, and the fact that the people that even created it don't know how it works. And we have these emergent capabilities that no one even understands what it's possible, we didn't know this was possible prior to last year. And we got a lot of positive feedback in demystifying this technology. And so this year, we're going to dig a little deeper. And we're going to pick up exactly where we left off. And the main takeaway from last year was that AI intelligence is not the same as human intelligence. It's using massive amounts of data to predict the next word. Now, this year, we're going to dig a little deeper into this. And specifically, what I want to be focusing on here is the data component. And in talking about this data component, we're going to be introducing some new terms, and we're going to be looking at a real-life Dscout example when going through this. Now, I want to talk about how this data is used and also show how we can use it in our own products. And I'm hoping by the end of this that when you're evaluating other products out there, you have a better idea of how your data is being used and how you can use your own data to make better products. Did anyone guess what that was? Anyone saw that coming? Okay, so these LLMs are trained on massive amounts of data. Each one has their own unique data and their own unique set of parameters that they use in training it. Where you might have ChatGPT predict word, you might have Gemini predict response here. You might have Copilot predict best word. They're all unique, and this data that's underlying it drives this. I even got this response, which I thought was quite hilarious, and is the most AI response you could possibly get. The one thing I want to point out here is it's actually really important, and I'm surprised it said this, is the simulating the appearance of cognitive abilities. And I think we commonly forget that it's actually not cognitive in the responses, and I think everyone should take that away from here, is that we start to forget that, and it's definitely not thinking the same way we are. You all have heard of at least one of these LLMs out there. And how do we interact with these? We provide some text input, and we expect some text output. This is where I'm going to introduce the first term today. And the way that you interact with these LLMs is through prompting. Everyone's familiar with prompting here. So I wanted to start with a very basic term that we all feel comfortable with. And in response, we get the response. So this is the exact example I gave. And you can see that you have to provide it some instructions in with the prompt as well to predict this next word. Now, yay, we covered the first term. Everyone felt good about it. It was super easy. But I'm going to apologize right now. When I defined LLMs, I mentioned trained, and I just brushed over the topic. And we're just going to go back to this idea of training because this is a term that I've been seeing the most confusion around. And that's why I wanted to cover this today. And when AIs are trained, this is when they take massive amounts of data, often petabytes of data, and they structure it into prompt and response structures. And these big companies use thousands of GPUs, and they train these things. They run computational programs for weeks, sometimes months, to get these models. This is computationally expensive and super cost expensive. And so there are only a few really big companies out there that produce these really big models. However, there are a lot of a little bit smaller versions of them. Now, the important thing here is that when they train these, you have to structure it into prompt and response structures. And so what I want to do is go through a real-life example here and talk about how we can use our own underlying data to improve these in a real-life Dscout example. So it took me a long time to figure out exactly what example I wanted to present today at this CoLab. We have done so much research over the past year, and we had all kinds of POCs that are really exciting. But I ended up deciding to talk about something that released to general availability production back in July. And so this is actually a question-level theme filter. I think most people in here are probably familiar with it, but if not, I figured I'd just briefly talk about it here. So in Dscout, you run an unmoderated study. You might have 20, 30 questions in your study. Some are open-end, some are screen share. There might be 5-minute videos in there. Let's say you had 100 different respondents take this mission, right? And so going into this and trying to do analysis can be very overwhelming. Has anyone experienced that? Okay, I see 2 hands. Maybe I'm a little off. And so in doing our research, we decided we were going to help researchers tackle this problem. And so we landed on this particular feature. What we wanted to do is at the question level, provide a qualitative theme list of commonly occurring themes within that question. So you very quickly click on each one of these and see the responses that are related to it. The idea giving you a jumping off point. Now, we're going to go through this and build this together today. But the main takeaway, or one of the main takeaways here, is that after months and months of work, this is actually a really hard problem. We are now seeing about 25% time savings in doing the analysis. So it's a huge benefit. Okay, so let's start doing this. And so I mentioned we work with these LLMs through prompting. Now this can be through an API as well, but I figured this is a better visual way to do it. So here's the prompt I first came up with. Again, we might want to put a little more in this, but to put it on a slide, let's go basic here. So what I did is I told the LLM I was going to provide a question, unique responses, and I want a bulleted list back. I give it the question, I give it the responses, and remember, we're building a product here. So the output, we need it to be structured in a way that we can automate this and produce this type of interaction for the user. Surprise, surprise. The output is not what we need it to be to produce this. It started out with some sort of weird paragraph in the beginning. I ended up having to use dots here because it's super verbose. And then it also just created a heading for my bullets. Some bullets had sub-bullets with definitions in them. It was nowhere near what we wanted to do. Sometimes it would say I, it used words like some, most. Sometimes it even hallucinated. So we have to be careful with this. I told you we were going to talk about data and how we can use data to improve this. And we have two major ways in which we can influence this output to be higher quality for our needs. One is through changing the prompt, putting more data into this prompt. And the data that's actually in this prompt is called context. So this is another term I want to bring up today. There's some confusion around context versus prompting, whatever that might be. Context is the information that you're putting in this prompt or the information that the LLM is using in that next word prediction. It's the actual text itself. That's one method. Now, the important takeaway I want to bring up here in this method is that you can inject real-life examples here. You can put in your real data. And when you feed this to the LLM, that data is not being put into the model itself. It's only being used by the model at time of prediction. So that's a huge differentiator. So when you go to ask questions around how people are using your data or how you're going to use your customers' data, this particular technique, you're not injecting it into the model itself. Now, there are certain pipelines you can set up with these LLM providers that are called like zero retention, no retention. That is a very important thing to consider when signing up, because I'm saying it's not put in the model at this time, but if you don't sign up for one of those, they can use your data later to then retrain a model. So definitely look at the details there. But I want you all to definitely take away today that when you're using data in this way, and if you have that type of pipeline, your model is not going into, or your data is not going into the model itself. From our experience, we found that as you're starting to work with this technology and build products, often this type of approach is a good way to start. The other option that you have is actually changing the model itself. So you can see there's a little highlight over here on the little sparkles. It's hard to see on this, so I wanted to point it out. But this is where you might actually go with a completely different LLM to change the output as well. So say for this example, I use ChatGPT 3.5. I might consider using 4.0. I might even consider going with a different provider like Google Gemini or Copilot. Now, you can even take this one step further, because I haven't talked about how we take our own data and influence this LLM, right? And so what you can do is you can take your data or your customer's data and structure it into prompt and response structures and inject it into this model. Now, the model has already been trained, and so you taking this data and injecting it in there is termed fine-tuning. And so I think we should differentiate the difference between training, which is the initial creation of the model, and fine-tuning, which is where you're taking your problem-specific data and essentially training just a few steps further, but they call that fine-tuning. Another important takeaway here is when you fine-tune, you have to be very careful, because what you're doing is you're saying, remember this data, and specifically remember this data, and start to forget the other data that you had before in previously training. And so some of the emergent capabilities that were there in the model start to disappear. It starts to memorize the responses. So this is where it can actually start injecting exact responses in there rather than like making up the best mathematical probability response. And so when you're taking these two different approaches, I want you to take away today that when you put it in the context, the model's using it at time of prediction, it's not going into the model. And when you're fine-tuning, the data is actually going in the model, and the model is remembering when given this prompt, or when giving this prompt, this is the response. So now I'm hoping we've covered prompting, we've covered context is in the prompt. Prompt is how you interact. Context is the data that's in the prompt. We talked about fine-tuning. And now what we can do is ask better questions about building our own products, how people are using your data in the products that they have, and now we can take our problem that we've been solving one step further. Okay, so now back to our problem. So this is my initial prompt. Obviously, we already learned it wasn't going to get us there. What are our options? I said we're going to go mess with the context because that's often the best way to start. Let's start creating some options. Option A. What we can do is we could see some issues with the response and just start adding more and more instructions in here. These could be guide rails around don't talk in first person, use a neutral tone. Here's some specific examples of the output structure that I want. Here's some actual specific data. Now, last year when I talked to CoLab, we were baffled by the 8K context windows of these models, which means you can put like 8,000 tokens, which is, I don't know, remember how many words, but a lot of words in this particular prompt, and we were blown away by it. But now the common size is like 128K. So you can put a ton of stuff in here for the model to use. Just remember, as you add new lines, the model does start to forget other previous lines. So every small change, you have to reiterate and check everything you've done previously, because it can just start forgetting things or not paying attention to your instructions. So here's another option. Option B. So there are tons of different prompting techniques out there. Right here, this is a chain of thought approach. I recommend getting online. There are tons of classes out there, figuring out the pros and cons of the different approaches. There are new approaches every single day. The idea of this approach is that with a complex problem like this, what you might want to do is break it into sub-steps. And what the AI will actually do is go through this in steps and check its work along the way. Instead of producing an output all of a sudden, it'll produce outputs until it gets to the very end and then write out what the final step is. I think that there are several papers on different minor changes to this as well, but I highly recommend just starting to get familiar and playing with the technology. You can also include, like I talked about, the guardrails here to help prevent hallucination, as well as some of the other things that I talked about. Don't use first person and use tone. Okay, so now we have two options. How do we know which one's better? This is where human evaluation becomes very important. And this is what's very different about working with LLMs compared to old AI, ML technologies. It's so subjective in terms of what's good and how to iterate on this. And so here we have the outputs from both option A and option B. And so what we did at Dscout, and this was a 9-10 month process and very difficult, was we worked with our UXR team that we would do iterations with the tech team. Human UXRs would evaluate these various options and provide feedback to our tech team. And we've set up systems and documentation around this. And we just kept iterating until we got to the final output. Now, this was tens, hundreds of iterations, months and months of iterations just for one question and set of responses that I was showing here. We got to this point, yay, all done, right? Not quite. When you look at a study, you have screen recording questions, you have video questions, you have long response, short response. You have some studies that have 10 people participating, some that have hundreds of participants. So what we need to do is set up a big design of experiments and have our UXRs evaluate all these different question types as we made small changes to various prompts along the way and use this ranking technique to keep track of everything to get to a final solution. And in the final solution, we ended up with what we have today after 9-10 months of hard work. And I've done a lot of hand waving here because the end solution ended up being 6 or 7 different complex pipelines to get to this type of output, where we'll do checks along the way and try alternate approaches if we feel like the list is low quality and we have signals. And so in our evaluation projects with the UXRs, we started to note things that we knew were not high quality, or if there's more overlap in themes, or if there were some subjective terms in the themes. And so we'll actually evaluate different pipelines and present the best result to you here. And so it's actually quite complex. Now, I bring that up because companies are taking very different approaches to this. It's now easier than ever just to put an LLM behind a product, roll it out to the world and say, we can do all these things. And I think it's very important at this point, when you're considering any product or building a product for yourself, to look at this human evaluation piece and really evaluate how they're evaluating, how they're using data, because it's so easy to just build a product and say it's amazing when it's all the same LLM in the background and they don't have the right guide rails in place. And doing these evaluations and setting up the guide rails is the hard part, and working with the tech teams. And that's something we've worked really hard at Dscout over the past year on. I want to leave you exactly where we started, that AI intelligence is not the same as human intelligence. It's using massive amounts of data to predict the next word. And how it's using that data can be done in many different ways. It's from training, you can put it in your own context, do fine-tuning, and the best, highest quality word for your particular application is really going to be based on the human evaluation that you do to get there.